a need that a company, a small company close to us, came in Brazil, that this small company, because now in Brazil since 3 years ago, we're experimenting a boom of construction, especially construction in steel. Because normally in Brazil, we do a lot of construction in concrete rather than steel, especially for buildings, malls, storehouses, and so on. But so since that need of building comes to that increase in steel construction, many small companies started doing business, and so does small company that build metallic structures. They have no experience and nothing related to welding, so they came to us and said, okay, we have a nice facility, but we are still working on welding, so first we need to monitor our process, and they come to us and say, okay, by no means we can use cabling because it's a large facility, so let's try to do something without cabling. So they came with that proposal to us, and so we developed the system. But apart of that, this project goes even further. If we look to ISO 9001, that says on its section 752 that a special process, and by means of special process, we have a lot of manufacturing process. And to be qualified as a special process, any process has to be measured all the time. I mean, in welding, for instance, we cannot only do final inspection. For instance, if you're going to weld stainless steel and we choose the wrong consumable, wrong wire, or wrong shielding gas, perhaps, and maybe we can get a final bead, a good bead quality, but so the inspector say, okay, there's no porosity, no lack of fusion, and there's a sound bead, but even though all the process were carried out wrongly. So it means that in a special process like welding is, we have to measure all the chain of production. And among that chain of production, we have, in that case, electrical signal for us. It's true for ISO standards, even in that case for ASME 9, that we have to measure all the welding energy. But if you go to ISO 3834, that's quality, basically, quality standard for welding, that says that we must include, that's highlighted in the bottom of the slide, that we must include monitoring and documentation of welding process. That's why we need to keep tracking on all the chain of production. All right? And what we should measure, okay? If you go to ASME 9, and we have basically welding current and voltage to be measured, travel speed, so we can calculate the welding energy. And if you look to ISO 17662, okay, depending on the process, we need to write down, we need to register base and field material, joint configuration, power source. For most of process, arc welding, especially in our case here, we need to measure consumables, what kind of consumables. By means of measuring, I must say that, okay, we need to acquire the data and to store that. I mean, it could be a simply, okay, that's consumable that arrives, okay, that's a 70S, a 6 wire, so I write down the diameter and the type of the wire. That's a simply measure. We don't need to really acquire the data. Which is not true if you have, for instance, to measure current and voltage values. In that case, of course, you can store simply the mean and the RMS values. It's true. Okay, 1 every second, 1 every 2-3 seconds. So that's what we really need. But if we are going to do a further step of continuous measuring the welding fabrication, we can try to acquire a little bit more. We can try to see, for instance, waveforms. And of course, we need to measure travel speed and wire feed speed. I mean, it's simple to do that. With a scale and a clock watch that it is, we need, but we still need to measure that. That's what's important too. And depends on the system, we can measure much other variables like radiation, sound, and so on. Okay, so yes, there are different equipment commercially available. You know, some very standard for instrumentation, like National Instruments. They provide solutions. Yes, not specific for welding, but in general terms, many manufacturers, Miller, Lincoln, they provide us small kits, not really for monitoring, but more for activating, deactivating the power source, but there are some wireless systems available. But even though we must develop our own, specific for welding, we'll show in a minute, and it has to be practical and simple. It has to be robust. You know, I normally say, okay, if the equipment is in the ground and some welder comes and kick it up, it should still functioning all the time. You need to be robust. And as a trend, we see that this technology is an allied for, like Professor previous present, like like to help man or the operator to control the process. I think we still are a little bit far away of having a complete independent system with no man following the welding. I think that will be accomplished in 10 years, maybe 20 years time, I'm not so sure. We see on the show different vision systems and automatic systems, but you still need someone, some people, some guy behind the joystick to control the system. So I think the idea here is to have a man system monitoring. And of course, we're going to use wireless communication as a trend. Ideally, what we have is different power sources in our system. We need to wirelessly monitor that, a little bit of homage or a remember of Steve Jobs. And we monitor